This
interrupt you.
conference will
Uh,
now be recorded.
before starting this webinar, I would like to share a few points to the trainees actually. Okay, so
Yes.
all trainees, all joiners actually make note of your queries. You can ask your queries at the end of the session. Just keep it simple and short so that others will have an opportunity to ask their queries. Okay, so you can proceed, sir. Thank you so much. Thank you.
Yeah. So I will be talking for about 40 minutes and then 20 minutes from 8:10 or 8:12, something like that. I'll let you know, and you can start asking your questions. Is that fair enough? I think that's what is the agenda that I have set with Srindra. And so I'm very thankful to Geek Learn that they have given a opportunity to COSMITUDE, and I'm very happy that all of you have come here on a Saturday evening and you want to listen up about something in data science, a boring subject. Let me tell you one thing. I like this storytelling part a lot. So this session will be like a story. Okay, so one thing is it'll be nice to hear, but you may sleep off. So just keep your pen and paper ready in case you have any questions. As Saravanan said, you make a note of it, and we can always come back and answer that. So let me start with the statement. Let me just dive in. So data management is evolution and movement towards exchange of data on the run and management of same on multiple systems with security and data integrity incorporated at every step. Just like any jargon in the tech industry or in the science industry, this is one more thing that I have written on my own, and it might sound very confusing and very some kind of geeky stuff. But let me tell you, at the end of the 14 slides that I'm going to show you, you will be thoroughly understanding this step by step. So let's dive in. Okay, so I will come back to this statement again in the last slide, and we will go in. We will just see what, as a summary, what we have learned. So let me just start with the next slide. I hope you are able to see my screen. Okay. So here, if you see, you're seeing a cave painting. Basically, this is a prehistoric cave painting in Anegundi near Hampi. You've all heard of Hampi in a Vijayanagar kingdom of 15th century. So this is not a 15th century painting. This is a painting which they say when you go there, the guide will tell you that it is a 10,000 BC, which is again 12,000 years ago. This painting was made. So if you see this painting, can you say that this is data? Can anybody say that, okay, this painting is data? Because as far as all of us engineers or data technology experts or anybody in the scientific space, we have this thing about data. Okay, this was a painting made by a person. Can we call this data? Uh, Maybe somebody will say yes, somebody will say no. But I would like to just tell you, data is something which we can interpret. If you see animals, they don't present any kind of thing. Like in 10,000 BC, I'm sure lions or tigers would have existed. They didn't make any cave paintings to give it to the future. Now, this guy who made this painting, maybe one interpretation, he came back from hunting and he drew this to tell to his wife and kid at home in the cave that, see, we went, all four of us went. Mr. X was here, Mr. Y was here, and we all four of us went. Mr. Z was on a horse, Mr. Y was here, and we hunted these animals. Maybe he wanted to show this to his wife and kid. That's all, maybe. Some interpreters today, they say maybe he sat in the cave and on the plains that were visible to the cave, this was happening and he recorded this incident. So there are many interpretations. So we can say that this is a lot of data. This is some kind of real-time data. And as humans evolved, you would have seen that many multiple ways we started interpreting, and we started putting our brain, whatever data was in our brain, on leaves. Leaf paper is what you see. And in 14th 15th century, books started getting printed. So anybody had an idea, he would write a book and it would get printed and it would get distributed with 5,000 10,000 copies across the world. So if you see in Europe, many of the books traveled from Europe to many places in America, Asia, everywhere. So if somebody learned a language, he would have so much of access to information. Now you see that videos, photos. As I said, in the modern world, I've shown you a small baby elephant with a man. That's a photo. That itself has so much of information in it. So now the information is getting bombarded from all places because of lot of storage devices improvement. If you see, we have these many storage devices, which I don't want to talk. You all know it better. But if you go to Wikipedia and search, or if you go to Google and search, it says what is data? Data are individual facts, statistics, or items of information, often numeric. This is what we hear about data. When data comes in, everybody is talking about 0 and 1, or some pictures and videos stored in 0 and 1. So data has become an intellectual property of only the computer world. So this is the agenda which I wanted, the first agenda what I want to set. Data is not just 0 and 1s, it is an evolution. So this is there in the statement which I told you, and this is what I want to set as the precedent to this 40-minute discussion that we are going to have. The first thing is data has evolved over a period of time. Data has evolved, and now we have reached the information age wherein we are storing it in data hard disk and other things. So first precedent set. So from 12,000 years ago in 10,000 BC to 2022, we have come and we have set the first precedent saying that data is there. It's there everywhere. The DNA has data. Cave paintings has data, leaves have data, trees have data, everywhere data, tree leaves have data, books have data, videos have data. So data is everywhere and it has evolved. So the first precedent I wanted to set, and I have set the same. Now let's go to the next thing. So what am I going to talk about? I'm going to talk about the elephant in the room in data transport standardization. Let me put it straightforward. I am going to talk about elephant in the room in data transport standardization. Now, I'm going to talk about data transport standardization as a small subject within data science. But what is the elephant in the room? What does it mean? I've shown a picture. Picture speaks 1,000 words. Okay. Now, these are the experts. Let us say it's just a picture, common picture from the internet, and they're discussing about data management and internet and so many other things. All we, technology people we discuss about. But they are missing a point, is what I'm trying to say. Now, I'm not claiming that I'm some genius. I am getting the point, but these guys are not. I'm just trying to tell here through this picture that we could not get to this point because the technology had not evolved. After 2010, 2015 space, the technology evolved with APIs, JSONs, and other things, which I'm going to talk more about later, because of which we are able to face this problem today. The elephant in the room is seen. Before this, the technology expert would have sat there and not seen the elephant. Now they're seeing it. Okay, something similar, okay, is something what I want to talk about, and just say more standardization required in data transport. So the question or the problem statement is elephant in the room in data transport standardization is the problem. And what is the solution? Again, I'm not doing a wordplay here. More standardization required in data transport. I'm just trying to put a statement here, but in the further slides, we'll talk about how we are doing a standardization required in data transport, how things have been solved at a very major macro level, and at our own company, how we have done certain things. I'm going to explain you with more, examples. So I would like to first start with a correlation. Whenever we talk about any subject, I believe in correlating. Now, what do you mean by correlating? If I say liquid to a 3-year-old kid, if I say liquid, L-I-Q-U-I-D, they may not understand. But if I say water, or whatever mother tongue, in my Kannada is my mother tongue, so if I say Neeru to my 3-year-old kid, she will understand. But if I say liquid, she's not thought about liquid. So it's better to correlate. If I want to talk about something, maybe Pepsi, Coke, or something like that, if the kid doesn't understand or can't interpret Pepsi, Coke, if I say it's a liquid, they may not, but it's kind of water. If I say, they will be able to correlate. Similarly, when we are talking about technical subjects, if we correlate things, the interpretation will be better, is what I generally feel is good. So I'm just taking a correlation here. Again, this is a very vast subject. I'm going to take a correlation, try to end it in 4 to 5 minutes, and then move forward. So if you have any questions, you can ask about this and discuss about this later. Okay, so what I'm showing here is a trail. If you understand, or if you are from a rural background, you'll always see that there are some roads and there are a lot of trails, like even between farms, there are trails where a human being can go. Usually these trails were formed thousands of years ago. And most of these trails are by experienced shepherds. Usually shepherds used to take their goats and sheep and, walk across the countries. Okay, shepherds didn't have boundaries at all. And mostly they used to go through the path where water was available and where the land was easy to navigate. Okay, and when they reached mountains, they would search for passes. So this way, the animals also used to help them search passes. They used to have dogs which used to search routes and other things. So trails were made by human beings. Now, why am I talking about trails in the data subject? You will get to know. Now, this is Hebbal flyover. This is one of the most busiest flyover in Bengaluru city where I reside. Okay, this actually connects our city to the airport. This was built on a lake area. The lake still exists, and there were railway tracks. So many things were there. So many things that were blocking it. So they built a very huge flyover. I have put a photo from the internet, so don't mind. It's not very clear. But what I want to present here is a trail that existed in Hebbal about 150 years ago was made into a small road about 35-40 years ago. And then in 99 to 2004 period, this was converted into a very big flyover. One of the first things that we saw in Bengaluru, which was so huge after the town hall flyover, which was long, but this was very complicated. So we were like, wow, a trail got, when I was a kid, it was a small road, Bellary Road, we used to call it. And that became such a big, this thing which we could not interpret. But now when I see it, when I look back, the trail, which was just a place where, a cycle or a man could walk or something like that, is now transporting thousands of vehicles of different types. I'm insisting on different type vehicles, cars, scooters, cycle, even a man can walk on that road, and then autos, buses, different types of trucks, electric or diesel or petrol, whatever. So what I'm trying to tell here is the same trail has been, modified and made bigger. See, if you go to the gazettes of any country, right, you will know that a trail is a is common to every human in that place or anybody using it. You cannot build something on a trail and say claim that land. So basically, over a period of time, trails have become roads. So government actually acquires parallel land to it and makes bigger roads. So what I'm trying to tell is these trails have got modified into bigger roads. It just doesn't stop there with human evolution with respect to transportation. We have ships, we have trains, we have planes. All these things also have evolved. It is like steam engine to electric engine for trains, and then with wind energy, ships used to move around. Now it goes with nuclear energy also. So planes also have evolved from two-seater, one-seater to hundreds of seat planes. So over a period of time, this has evolved, and now we have drone technology also. Now I have already elaborately tried to finish around 10,000 years of history of transportation, from where we were just walking or on bullock carts or on bicycles to whatever we see today. Now, what is the correlation? The right hand side is still pending. So let's go to the right hand side and see the correlation. Let us see the correlation with respect to data management. I will talk about this in 3 different blocks. The first block, again, these are very vast subjects which I'm covering 2-3 minutes. So just bear with me. You all know these subjects here and there, so just don't worry. Just bear with me and just listen to me. Okay, I may miss out many points here with respect to the depth of the technology, so don't worry about it. So when I say internet, I say okay, it might be TCP, IP, or HTTP, or any kind of G, 2G, 3G, 4G, or even fiber optics, or even fiber C cables. All this comes under that. So it is basically the trail wherein we pass the data, the transport layer basically. So if you have studied about the OSI models, I'm sure you would have seen there is a transport layer. From the application layer, at the end of it, you have a transport layer. So basically in data management, we use that to move data from one place to another place. Okay, so the final transport layer. So I won't delve into that OSI layer subject. I'll just go to the next thing. Then what we do, we have computation and storage. So we have CPUs and storage devices, hard disk, RAM, etc., which will help us do the computation and store data. So these are either in our machine, like I have a CPU and this thing which is broadcasting this session to you guys through a server. Now the server is again maybe in a cloud storage or in a distributed cloud or wherever it is, go to server, and then you guys are seeing maybe on phones or tabs or whatever devices. Finally, we have this system in place. Basically data is getting managed like this. Now to connect these things, if you had started your career sometime in 2004 like me, you would have seen only XML, okay, and then HTTP protocols that were starting to evolve, and HTML and other things. But now we have so many other languages, so many other things, and then some of the interesting things is the API and the gateways that have evolved. So APIs let you consume data from one system to another system in a very simplified manner. Okay, those were not existed. Again, to standardize further, they brought in JSON. JSON is one of the most used nowadays. I am not very much going into the depth of what J2E did. Okay, J2E is Java 2 Enterprise Edition, or which talked about stub and skeleton, or I'm not talking about DCOM, COM, and C Sharp WCF, which gave more power to the developer to access things. These were even predating the API days, when systems built on the same technology of Windows could access on other systems very easily using WCF or DCOM or COM. And the systems which were built, both the systems, if they were built in Java technology, then using J2E, connecting them were pretty easy. But over a period of time, it evolved to such an extent that APIs and JSONs have become kind of standard. So I have built a correlation here, and now I want to make the statement. So the first statement, what I try to make is data transport standardization. Please write down this statement, whoever has a pen and paper, and who has not got it, just remember this statement. Data transport standardization is the first statement which I want to make. Data transport standardization. And then I make the second statement. Just observe what I did was I just clicked my keyboard and I got a trail-like thing between these three sectors. On the right hand side, I got a trail. I got a small trail. So what I'm going to make is the second statement. Data transport standardization was the first statement. My second statement, a very bold statement I'm trying to tell, you can discuss on this, but I want to do it, is in trail stage. It's not trial. It's not in trial stage. It's in trail. It's a trail. It's very primitive. When we talk about data transport standardization, we are still in trail stage. Whatever was there in olden days for people, it's like that. These systems are totally disconnected is what I feel. Though they are very well connected, though the speed is increasing between them, to connect to systems, we don't have a system that helps in standard transport or standard protocol. If to give you examples, I'll go further. So here, this we have already discussed for the last 5 minutes. On the left hand side, we have already discussed. Okay, I'm going to talk with this to specific to a sector, the UPI magic that happened in India and money transport standardization. What is this UPI magic? Unified Payment Interface. We all heard about it in December 2016 when apps started coming. The first app was Beam app, and then Google Pay came, Phone Pay came, then Paytm came, so many other apps came. Okay, but even before that, by the time of 2013-14, many private banks like HDFC, ICICI, and some government banks also had their own apps. So what was this unified payment interface? Basically, the government of India came up with a plan to have a standard interface. If you see, observe here, there is something called a standard interface, and told all the banks, see, you have to follow this standard interface to push in your data and to pull your data. And they also did one more thing. They did KYC, know your customer, wherein the banks used to always know their customer based on their account number and IFSC code. But then government of India added some more things like Aadhaar card, PAN card. All these things should come into your banking system. It had already come into an extent, but it was still broken. But they did it in a faster pace. And then they added the phone number also to be part of the KYC. So basically the three things: phone number, PAN card, Aadhaar card. Like this, many things. At least double verification was linked to every bank account. Along with Jan Dhan accounts, this was done at a faster pace, and a standard interface was done. Now, after this, what happened was unified payment interface only with 3 public sector banks it started, and then after 2016, all the public sector banks started coming in. Even the private banks which were telling, no, we have mobile application, we have internet, everything. Why do you want it to come into our architecture? Understood it immediately. Okay, now the transaction can happen from any bank to any bank within seconds, which means nobody has to type in IFSC code, nobody has to type in account number, nobody has to log in. They just have to have an app and transfer money to wherever. Okay, so they also came in, and unified payment interface became the core architecture to transfer money in India. What was the need for this architecture, and what is the use of this architecture? We have to understand. Then we have to understand the vision here. The vision is straightforward and simple. We want to make money transportation from one place to another place a standard. So we don't have to worry about pushing money from one place to another place. It's not take time. And one more thing is, if 100 rupee I go to an ATM and borrow 100 rupees, take 100 rupees, come out, and I buy vegetables. Then that 100 rupee goes to the vegetable vendor. The vegetable vendor goes to the next day market, wholesale market, and gives them 100 rupees to the wholesale guy. The wholesale guy gives it to his driver. The driver gives it to his wife. The wife gives it to the school of the child. The school of the child gives it to somebody. Like this, a measurement is made that a rupee taken out of a bank actually travels at least 25 times and comes back. So 100 rupee taken out 25 times, if it is coming back to the bank, so the bank is only seeing 100 plus 100, 200 transaction. 100 rupees somebody gave and somebody gave back 100 rupees, 200 transaction. But actually it has gone through 25 more transaction. It is actually, its transaction worth is 2,700. But with unified payment interface, I don't go to the ATM. I buy vegetable and use my app to transfer the money. And he uses his app. Like this, lot of cash transactions started coming into the money transport standardization. Why I call this money transport standardization is because the government, through the laws and through UPI, built a kind of standard between these systems. Visa and MasterCard tried to build it, and they had built it. Visa, MasterCard, and American Express, they had built a standard, but they had their own contentions. You need to have some swiping machines, this, that. But government of India, after a point where I'll tell you more about Aadhaar and other things, which was started in 2008, they started seeing that this could be done, and they did it. And that was the beautiful point. So they finished with many years of work. They finished a UPI, and today it is considered a standard across India. With a phone, you don't even have to carry 1 rupee cash or a credit card, debit card. You don't have to carry a purse. With your phone, and don't forget the charger, you can travel throughout India today in 2022. Now, what am I trying to pinpoint here is this. In 2020, during the pandemic, government of India, through this NPCI, NPCI is basically the government of India institution. They announced that Singapore wants to, do the integration. So Singapore will also start using UPI. Singapore also will, enable this UPI system in their island country. It's a big win. Singapore is like one of the hottest destination of business, and worldwide it is a country which is always talked about for standardizations and other things. And Singapore has accepted Indian technology, and they are going to implement it. But it was announced in 2020 that it will be done in 2022. So it will take almost 2 to 3 years of work to again integrate another system into this system of UPI. UPI itself was an integrator. Now to integrate another system, because see, Singapore will have their own interpretation within banks with respect to account number and other things. So there must be some standard to be built. So to integrate these systems, again, it will take 2 years. These are complex systems, I agree. But what I'm trying to pinpoint here is, when this happened, it took 5 or 6 years, 3 years to build, and then 3 years of standardization happened, and now it has got to a very high standard. Again, when somebody has to be included, it takes a lot of time. Again, if something changes, for example, in the recent budget, it was announced that blockchain will come in. RBI will implement blockchain for the rupee. So again, the architecture will change in major ways. Again, everybody will have to interpret and make changes if required. Okay, so the whole concept of making these things simple for money transport standardization has been done as on date, but it is still not data transport standardization, is my claim. So actually speaking, here we see that money is getting transported, no, from one account to another account. It's actually the data from one server is going to another server. Anand owns something and is given 100 rupees to Sudhindra. It's going to Sudhindra, that's it. Sudhindra gives back 100 rupees, coming back to this thing. This is what we see it as money transportation standard, but actually it is a kind of data transport standardization within the space of money in our country, within this financial institution. But still, there are many things, postal, insurance sectors, many things that come into this. But I'm not going to talk too deep into it, because this is away, I have set the stage for what I want to tell. So I still say data transport standardization should happen. Though UPI is there for this, it is taking longer time. If there was a data transport standardization, it would have taken very less time. How less? Let's see. Again, the right hand side and the left hand side, it has been set on your screen. I showed you about this. So I'm just going to talk about some of the projects that taken up by Government of India to bring in this data transport. I'm not trying to push the government agenda here. I'm telling this thing because for the correlation, it has been done from a very long time. It started from 95, 96 times when computers started entering the government sector. But then it took place with Aadhaar, and then the Beam application UPI by NPCI, and then now we see FASTag. FASTag is wonderful. Huh? One of the times when I felt the power of FASTag is one afternoon when I was going towards Hubli from Bangalore. Somewhere near Sira, I saw that 3 government cars were buzzing. They went fast. I was going in a Wagoner at 80 and they went at 120 in a Innova. And 2 minutes later, we see that the toll comes. I was using FASTag just a few months ago. I was using FASTag. It was afternoon. There was nobody. I went, I stood in the FASTag. I see on the left hand side, those 3 cars were standing because the watchman was coming running. He had put a barrier there for the VIP path, and I, a common man, like a VIP, I stood there. FASTag open. I moved ahead. Okay, for 5 minutes they could not come because this thing was blocked. Again, they bus back. They went at 120 and they crossed me after 5 to 10 minutes. But those 5 to 10 minutes, I felt like a king because I was not a VIP. I was driving a normal, ordinary Maruti Wagoner car, and I could beat these guys because we had a technology through which digitally money got cut and I could move forward. So this is something which I talk about, which changes things for normal people like us. And then even sensors, now today they are trying to integrate with many things, and they are going to bring in integration from devices and everything. But again, Government of India has to build all these technologies one by one. Like one more thing, what they have announced is ONDC, which is Open Network of Digital Commerce. So they're going to integrate NPCI, Aadhaar, FASTag, everything, and then bring a logistics system in India so that shipping containers and lorries, trucks, everything logistics that is there, which takes logistics itself takes 14% of the transportation cost in India. While in developed countries, it's only 9% because it is efficient, like our traffic, road, etc. So many problems are there, which they are solving one by one. And this is a very big plan, which was done after liberalization 91, 92 times. It was done, and it has continuing in our country, and has come up to this stage. But for everything, they have to build new apps. They have to build new connectors. Now that is the costly part, which I'm trying to explain here. So whenever the trail here, when I show you a trail, right? Whenever the trail has to be converted to a super highway, you have to go and build a road there, which is a costly and a time consuming process. So though they are doing many things, the technology today only says this is the way, boss, you have to do it. When somebody has to integrate, for example, if NPCI apps, UPI apps has to integrate with FASTag, then you have to write all the connectors. If it has to get integrated with Aadhaar, you have to write all the connectors. You may say there is JSON which is giving data properly, there is API which is giving data properly. But if the Aadhaar system and the FASTag system are working at different speeds, then itself you have to write a new module which does the load balancing between the two, which we have seen very clearly in the income tax portal that we saw of government. It was falling down, coming up. Now it has stabilized, but it was falling down for more than 6 months. The reason for it was the systems that were integrated were not on the same pace, so they had to make it proper. And what used to happen was from evening to early morning there was no data transfer there, but suddenly during 11 to 1 there used to be huge data transfer, because of which the systems were falling apart. So there was no load balancing system in the middle. They wrote connectors, but again they needed load balancer system. So every time you write something, you just don't the API and you consume it, it doesn't happen. You need to know how much of data transfer you can do, at what time, at what frequencies, and then you have to write a load balancer which manages it. So basically there's no data transport standardization that is set in the industry, which will take a lot of time. And what they have done, they are doing, but with the current technology, with current proven technology, because government doesn't go with technology which people are telling in shows like this and seminars like this, and they won't accept. They will take their own time. They'll have to interpret, because it is at a very high level and with lot of data. So here is where I'm trying to pitch in the next this thing. Do such data transport standardization solutions exist? Okay, I talked about the problems. Okay, now I'm trying to tell, do they exist? Yes, for some cases, yes. For some use cases, to be very deep into technology, for some use cases. For example, let me talk about SaaS-based data exchange platforms like Segment. Twilio Segment, you can see here at the top, they give any kind of a data exchange for SAP ERP systems. So if you want to connect to a SAP ERP system and you're a very small player with very less amount of data going in and coming back, it will be very costly to implement the entire SAP ERP protocols all by yourself. Instead, you use Segment. They give their SaaS. Through their SaaS, you send the data, get back. You don't even have to call the SAP ERP API directly. You just call the Segment API. You get back your answers. Similarly, for Microsoft 365, Azure, and other things, Python is built. They're all $25 million, $100 million worth companies today. Okay, they have only solved one use cases. I'm not telling only one. They have solved one use cases with respect to SAP ERP or Microsoft 365, and they're also expanding their space. So slowly and steadily, they're building, data transport standardizations in one sector. For example, Mendix, they do it in industrial automation sector. It was acquired for around $1 billion by Siemens in 2018. What they do, if you have a factory floor and you have some industrial data coming in and it has to go to an AI system or something, they have special protocols built which help you do that. Similarly, in IoT data exchange platform, there's Davax and Thinkful. They are doing only with respect to IoT, and you can see a lot of IoT, AI, ML, even in data clouds like AWS, Azure, and GCP. Again, there are RPA software. RPA softwares are older, like UiPath. It was built from 2004, and have a lot of customers. They are worth about $35 billion. Their value, UiPath, in the New York Stock Exchange today, and they are they are the ones who help you build your screens and everything in a very fast way. But still, I claim that we have a solution better than that. Okay, now this is not an advertisement, but I will prove through some of the examples and then go forward. We built, these are smaller examples. I'm not talking about the bigger examples like UPI or wherein the money transport happened, or the other things that the government is building, or something like Segment and other things. I'm talking about one solution which a research firm required. The research firm had a beautiful machine learning logic which was on normal computers, which they were planning to move on AWS. Now this machine learning language had to get data from 5 different websites for one research topic or research. They would have written some 250 lines of research things, which if they pass to the website, they would get some interpretation. They had to take that interpretation and manually put it to this ML logic, which was like, very cumbersome for them. So they wanted an application which could do that. So they went to many people. They're a small firm in Bengaluru, and they had about 58 people, 58 researchers. They're a small firm, and everybody was asking for a lot of money, or they tried to build it themselves, having 2 IT resources. But that also, they calculated that it would take about 8 to 9 months to have a proper system, because they had to have proper stabilization from 5 different websites. If one also failed, what should happen? All these stabilizations had to come. So they saw that it was about 6 to 9 months work, and they did not feel it was very easy. Then accidentally, I met the CEO of that firm. Told, we'll do it. So how many days, how many months will you take? He asked. I told, we'll do it in 2 days. He didn't believe me. Point blank, he didn't believe me. I don't, this is the amount you have to give, we'll do it. I'm not mentioning the names because they are my clients and they weren't some this thing. And he also told, we will not give you the ML logic. We are not going to give this ML logic because this is core to our company, and we are not going to give the ML logic. So what we did, we built a dashboard. So half a day, I met him on Saturday. On Monday, we started the conversation. In half a day, we took the requirements and built a small dashboard. One of our developers built a dashboard. Another developer, using our protocols, the template and forum, we have a creative tool. They built a logic which would go, we didn't write logic, okay? So we get the data, whatever, some 250 lines of data from here. We have a bot which pushes the data into the COSMITUDE bridge, one of the forums. And from here, the data goes to these 3 websites give the same kind of, have the same kind of API. So 3 websites, 1 bot gets the data. Another 2 bots get data from these 2 things. And then one by one, they give it to the ML logic. The ML logic crunches the data, which is on AWS server. This whole COSMITUDE bridge on SaaS, it is on Google Cloud Server. It gives back an interpretation. And finally, the data goes back to the monitoring dashboard where they get the interpretation. So whatever was, a 9 months project got over within 2 days, and they even verified it in the next 3 days, and within 5 days, they had this because the data transport standardization existed through COSMITUDE bridge. We sent the data was moved very fast, and these builds, these joins were done in very fast. And we never saw what their ML logic is. It still runs on AWS. It just goes, data hits it gives back an answer, and it comes back. That's it. So here they're getting the secret part also very important. The secret part of whatever happens on an AWS or whatever happens within your company, the core logic, you can keep it secret too. So this is kind of a standardization in data transport, ensuring that we don't know what somebody doesn't want us to know, because that is their core logic. Something similar we did for an insurance brokerage firm. They had acquired 20 plus firms in 2020 during the pandemic first stage, and some of them were Turkish, French, and Spanish. It's the England-based firm. So all their database servers, which is kept in a data center in Mumbai and Pune, is basically having this entire data center, which I'm showing. It's not a real photo of that company. All their databases exist there. Okay, and they have only Microsoft-based systems, and they use Azure. So they had a translation AI system, which would take the Turkish forms and translate and give it to they had built a translator for Turkish, French, and Spanish using AI. Now there were more than 20 plus firms. Now their agenda was to have a connector which would, as and when they had acquired more than 20 firms there, all some 150 people firms. They're all insurance brokerage firms. So when they collected forms at a local place, because they were going bankrupt, they sold themselves to a bigger insurance brokerage firm, which is our customer. So they bought this, and all those employees continued their work. All we did was we wrote these bots. So we wrote 3 common bots: for Turkish one bot, one French one bot, and Spanish bot. These used to push the data into Bridge, and Bridge used to send it to the Azure translation AI system, which is again proprietary code of our client, insurance brokerage firm. They would interpret that and send back the form. So, and we would send back to the database. The database already has a standard, because it's a huge insurance brokerage firm. For the world, insurance brokerage firms have a standard. Just like the UPI interface, they have a standard. So we just push the data in the exact format. And for that also, we didn't write code on how to do it. They had the code ready. Only what we did was the connection management. We did it within, I think this project was over within 3 weeks. 3 weeks time. So we took data from one place, put it to another place, and give it back. And why it took 3 weeks? Because we were dealing with a very big insurance brokerage firm, and they had a lot of protocols, a lot of bureaucracy within to ensure that everything goes smooth. Actually, if you calculate our work, it was again 4 to 5 days of work. So what I'm trying to say here is, because of data transport standardization of product sitting in the middle, things change dramatically. And I showed you 2 use cases, one with a research firm and another one with an insurance brokerage. Now let me just go back and see again the government systems. Okay, if you see here, there are so many things. So I'm claiming, nobody should accept this claim, but I'm claiming if we bring in COSMITUDE BRIDGE, it works. But what I'm trying to say at a higher level is, if we bring in a data transport standardization, forget the product name or whatever it is, if we bring in a data transport standardization through a product like this within the world, okay, it will change the whole dynamics. Because see, it's not just between all the products. You can put these kind of products between any 2 products and start interpreting. And the advantage of this system is, basically somebody using this system needs to understand this product only, the center product. He need not understand the API on the other side. He need not understand what is the load balancing required, everything. Because what happens is, these bots are trained to ensure that on a level, if there is any change, they try to interpret the change and evolve. Or they also scale to any ability. If the ability is low, they are at a lower rate of running. If the ability rises on the cloud, these bots multiply themselves and go at a faster rate. So this way they bring in stabilization within the system. So somebody is hitting a lot of things to the API, and the API cannot handle. Usually that's not the case. When reverse comes back, like when the API systems are, usually API gateways are too heavy loaded and they can take any kind of a load. But when it hits back, our systems go slow. So here this system sits in the middle, and automatically, not only does it have a standard protocol built in which helps you build the system faster, it also automatically load balances everything and reduces the time drastically. So if it takes 100 days to finish one work, it gets over in 10 days. And then the cost, when there's too much load, it multiplies on the cloud. When there's no load, it comes back to 0, which means you're not paying when you're not using. You're only paying when you're using. In fact, in our research firms, we saw that they had to purchase a server of 2 lakh rupees. Finally, they ended up paying us for only for the software and what they are using on a monthly basis, which is only around 5 to 6,000 rupees per month. So this is the kind on our SaaS. So this is the kind of change that you can bring in with respect to time, money, cost, everything, if we bring in the standardization in data transport. So what is the product? I'm talking about the product, but this is about data standardization. Data is always fragmented. It's everywhere. It might be a human input, it might be a server data, it might be AI, ML, IoT, anything. Okay, or some app third-party data, or data cloud, or even some social media things. So what we are trying to tell is, by putting a data standardization in the middle, data transport standardization in the middle, we have implemented that same 3-word data transport standardization, okay, into a product called COSMITUDE Bridge. By putting that, what we can do is whatever is coming as a human input can be transported into an AI machine on the run. So the bots will ensure that it goes to Bridge, and Bridge will take care of putting it to AI machine or IoT machine or some other cloud, or for some machine learning, or take it to social media, or get something from social media, and all the things can happen on a run. So you need not get worry about the connectors, because what we see is, if somebody writes something, some logic to do this thing, just like our client, they were writing a logic to take from 5 different websites, public websites, and they wrote a ML logic which would learn from that, okay, and then interpret the data and give back an answer to the user. So what would happen is, the whole process of building this ML logic would take 1 month. Then just connecting it to 5 different websites and then building a dashboard and then bringing all things together would take 1 more month. But here they built it within 1 month, the ML logic, and in 2 days they got the entire structure in place. So got drastically reduced. And the next part is, one of the websites went down and changed their API. At that point of time, it was just 1-line code change within this product, which was the data transport standardization layer, and immediately they had they are back. So within 10 minutes, they did not have to test their entire system to test to test the logic of getting the data. They just had to make the small change, and it happened. So many times when I explain the system, people say, this is low code, no code, or is this some kind of data management thing? Yes, this is a amalgamation of many things. But again, what we are focusing is on data transport standardization. So now I have given us 2 statements. Data transport standardization is in trail stage. But after seeing all this, we are trying to give an automatic superhighway. So what I'm claiming here in this slide is, we have given a superhighway. You just take this, whatever I showed as a trail, right? Fragmented data trail will become a superhighway for you. So you can connect to any system and make your path very fast and very efficient. And then let's go to the other system, other things. Just 1 second. Yeah. So what is the takeaway from this session? So I'll just take 1 more minute of your time here. This is like the summary of whatever we did for the last 42 minutes. Data management is evolution and movement towards exchange of data on the run, and management of same on multiple systems with security and data integrity incorporated at every step. If you say tomorrow morning, going to somebody that I did a session yesterday evening and this was this, I don't think you'll remember this. So let me just tell you, that was a statement. Data management is a word which people understand. Data science is some word which people would understand. But data transport standardization is what I'm trying to explain here for better data management. And that is what is the takeaway from this session. Data transport standardization, which will ensure that what is like a trail today, TRAIL, a small walkway, will become a super highway for us to connect multiple systems. So data transport standardization will help us connect multiple systems. So whatever was taking years will get reduced to days. Whatever was taking months will get reduced to hours, and whatever was taking days will get reduced to minutes if you have a data transport standardization systems. And once these systems are made in minutes or hours or days, depending upon the workload, then running it for any scale is a breeze. You don't have to do anything. It will run to any scale, from 20 users to 20 million hits. It can take. The cloud will take care of all these things. So these are the things. And the cloud also is not one cloud. You have to go with GCP, or you have to go with AWS. You can go with any cloud, or you can build your own cloud and run these kind of systems. So this will dramatically change the software industry in the coming years. This will, you know, punch a hole into the whole system and make sure that things are done in a very faster rate. So thank you for, you know, bearing and hearing me for the last 40 to 45 minutes. Now it's time for questions and discussions. I won't say question and answers because these kind of new topics will raise a lot of discussions. In fact, whenever I explain, there are a lot of questions which I have a set of FAQs, you can say. And it's okay. It's part of the system because we are used to the APIs and JSONs, and we know that we can build these systems. Then why do we need a data transport standardization, or why do we need a product like COSMITUDE BRIDGE? This interpretation I've tried to explain in the last 40 minutes, but still there will be questions and there'll be some discussions. That's welcome. If we cannot address it in the next 15-20 minutes and time gets over, then my details are also here. sales@cosmitude.com is the email ID, which will give to many people within my company. But if you want to write only to me, it is Anand. My name is there, ANAND@cosmitude.com, and the phone and WhatsApp number is there, so you can contact us through that also. Or we'll be very happy if you go into cosmitude.com and, you know, click the link, download Bridge app, and then connect over public forum and start asking us questions on Bridge. Anyway, that is what is there on the screen till we go through the question and discussion session. Over to Saravanan to coordinate the question and discussions.
Thank you so much, sir. It is very helpful, actually. So, guys, you can ask a question if you have, actually.
Hey, hi. I'm Joshi here. I had a question about once if you're standardizing the data that is being stored, so the data the source of the data can be multitude of locations, right? So what about the security of it? I mean, how we don't know. I mean, the data itself can can inject security threats. So how is the system going to possibly handle this?
Yes. So what happens is, whenever we build a system of this, okay, what happens is, if you see these arrow marks, when we build a system, when we use the creative tool and build a system, it actually throws out bots. These bots, right now we are giving in Python. We plan to give it in other languages also. So once the Python bots comes out, you can add your own security layer. By default, we give a security layer. You can add your own security layer, like AES 128. By default, if we give, you can make it AES 256. So we give you all the options within this. So data transport standardization, one of the main things is the security. Okay, and how we do that is, from your system, when the bot pushes any data, it would have pushed according to the algorithm that you want, according to the security algorithm you want. So from your system, when it leaves your system and joins the transport layer, when it comes into the bridge system, whether on SaaS or PaaS, okay, whether if it is PaaS, you are only owning the data, but if it is on SaaS, you're on our system. Whatever is the thing, once the data leaves your system itself, it is your proprietary. When it comes to the SaaS or the PaaS system, this system will not know anything about your data. Okay, so the security starts from there only. And then when it goes to another system, we push it based on your logic. Again, the bots on the other side are written according to your logic. So you can still write bots the way you want it. For example, when we showed you here, this system, whatever they had written, these bots and these bots, everything were generated by Bridge, but were running in their own secure environment. So when something was pushed from here, it has AES 128 security. Then when it comes in here, we don't know what is their algorithm, everything we don't know. We just push it to here. Okay, and here it gets decoded, and again they do the work on that to do the AI understanding and other things, build the form, and then encode it and send it back to Bridge. So again it comes encoded. Maybe they're doing different encoding here, we don't even know that. Okay, once they do the encoding, it comes, it sits in our system. It's kind of a, again there's a call from here which pulls the data, and again when it comes back, it might come in AES 128 here, go here, but here they may decode it AES 128, and then when they're uploading, they're doing AES for 256 or something like that, and then it comes here, they decode it using the AES 2, because all this inside the bot, what they are doing, we will give it to the customer. They can do anything. So end to end, data transport standardization doesn't mean that I will even standardize the security protocols. I will leave it open to the people, but we give some basic standardization, basic we do, because some of the customers may not even know about that. But overall, if they want something higher, they can do the way. I hope I answered your
So
question.
all this data is JSON, is it? When it moves out of the bots from like source to the destination, both the
No,
places
not
where
need
it
not be,
is.
need not be, need not be. In fact, we give a
Okay.
creative tool. Okay, the way we store data is on a NoSQL database. So you can say we move the data within ourselves through JSON, but ultimately their data, the customer specific data, ours is meta, right? Ours is meta. So customer specific data, we give standard protocols like text, video, then this thing, what is it? Image, then document, and we even give barcode, QR code, and RFID interpretations. So many things are there, na? Maps. All these things we have already inbuilt in our creative tool. So tomorrow, if there is something new inbuilt in the industry, like QR codes were not there 10 years ago, but they were built recently. So if something new is built, right, barcode was there, but QR code was not there. So QR code came in, we built that. Again, if something new comes, we just build that module. So you just have to pull and push that there, and it gets interpreted in the system. So data wise, for a user who is building the system, he just sees whether it is a text or an image or a QR code and just builds the screen. So my API wants all this, I build the screen, and ultimately the bot code is built. One click of a button, the bot code is generated. And finally, the bot code, when you run it, it will connect the systems. I hope I answered your question.
I have a question, sir.
Yeah.
Is the COSMITUDE bridge, is it a software or something that it has been fit in any of the logics that have been applied, and how basically does it work? I just want to understand.
Okay, see, architecture wise, if you want to know more about our product, you can go to cosmitude.com. Okay, like we have even published what we are doing and how we are doing and other things. Okay, so basically it moves data around. So it is a standard data transport standardization layer. Okay, it is a data transport standardization layer. So you want to move data between two subjects. It is a layer which helps you move data. So what I'm trying to tell here is, if you see the UPI system, if you replace this entire UPI system with COSMITUDE Bridge, the standard interface they have defined. All the banks they're pushing with respect to the standard interface, and they're getting back data from other banks. That's it, and they interpret in the standard way. Yeah, one bank might have account number as the first field and IFSC as the second field. Another bank might have as the fourth field the IFSC number. So COSMITUDE Bridge, what it does is it gives a standard interface. The bot will change that into the standard place, wherein the account number is the first, the IFSC is the second. Whichever way it comes from a different bank, the bank has to just make that standard interface correction in the bot and push the data. Finally, when it comes to bridge, it sends it to the other bank. The other bank receives it in the standard way and processes the data. So if you are sending money or receiving money or doing any other transaction like account balance transaction or something like that, all the standard protocols get built. So I'm just giving an example because it's easily understandable. So if we replace UPI with bridge, it's something like build protocols for different banks and exchange things. So they'll have some 5 or 10 different type of flows among them for money exchange and account balance and other things and KYC and other things. So if you build all those things, that's it. It becomes a standard. So any problem, whether I talked about this and I talked about these complex problems and even these SaaS-based systems and other things, then I talked about some of the research firms things. Everything is like that. We have to move data, but the problem here is when you want to move data from one system to another, when you think like a developer, it is okay, 2-3 days work. I know an API, I have to design for it and write some wrappers around it and then push the data. But when you go from the design and development stage and go into the real world, if your code is being accessed by 1,000 people at the same time, scalability is not there. But what COSMITUDE Bridge does is, whenever you have to think about the problem, you just have to think about the 2 or 3 lines of matching the code and making it hit that API. The rest of the code, the wrapper, is automatically generated by COSMITUDE Bridge, and then once the data comes back, you have to take care of pushing that data back into your system. So 2-3 lines code here, 2-3 lines. So 99% of the code will be written by the component here. So when you think from a designer and a developer's perspective, you will think that okay, 2-3 days of work and then it becomes no. You will end up doing 1 month's work. But instead of that, if you take at the design level, you will end up doing only 2-3 days of work, and you will get a system that will scale to any extent and do the exact work for you by reducing the time, money, all the factors. Hope you got it.
Yes, thank you so much, sir.
Yeah. So something more, if you want to understand, this is the place. Our website, COSMITUDE.com. I don't know if you are able to see on the screen, www.cosmitude.com. It's in the email ID also.
Yes, it is
If you
okay.
go here,
Yeah.
we have a lot of documentation. We have a small video and then a lot of documentation. Yes. Any other questions? Nobody asked me a question. One of the FAQ that I get is, if you, is there any question you can ask? Otherwise, I'll talk over the FAQ. Frequently asked.
Guys, actually hope you have make a note of this contact details. You can ask your question offline. Okay, we will circle back all the queries and answers and get back to you. Thank you so much. Thank you so much, sir. Actually, it was a very grateful session for us. As a data scientist, we would like to know more about data transportation and data management. Actually, so you explained us very well how data transportation makes our life easy, and in terms of security, in terms of scalability, in terms of finance, like that. And thank you so much, actually. So guys, you can ask your queries offline. Just make a note of this WhatsApp number and email as well. And we will get back to your queries, actually, definitely, for sure. Thank you so much, sir. Thank you so much for your valuable time.
And
yeah,
thanks to all the audience and Deep Learn team.
thank you.
Thank you. Bye-bye.
Thank you so much, sir.
Thank you. Bye-bye.